The DigiSim Unlmtd software consists of two main components. First, there's the offline programming environment, called the optimizer, shown here on the left. This is where the machine-specific programming is done. The second component is our 3D simulation environment, called DigiSim, which is CAD independent. These two components are actively connected to each other. This means that any change made in the programming environment is immediately visible in the simulation area, without time-consuming calculation loops. This capability is a demonstration of the software's high performance. Now we would like to give you a quick overview of the offline programming component and show you how simple and user-friendly this software is and how it can help you to optimize the die, the press and the transfer with each other in the best possible way. In the programming environment, the user interface is structured into an editing area and an evaluation area. The evaluation area provides the ability to display the relevant diagrams for a detailed analysis. This area is further divided into two sub-areas called Quick View and Detailed View. By selecting the Quick View, you can get an insight into the effects on stroke rates while programming the press and transfer. The Quick View also provides preview diagrams that give you a complete view of all press and transfer motions. In the Detailed View, you can see press and transfer motion diagrams enlarged and in even greater detail. This is just a small selection of the available diagrams. Interference curve feed lift. This diagram shows the total pitch, the total stroke length of the lift and the amount of overlap between the movements of the two axes. The interference curve close lift. This diagram shows the movement plane of the transfer clamp axis and the transfer lift axis together with a slight movement on the vertical axis of the diagram. This allows you to analyze the clearance between the transfer and the upper die. Order diagram for the slide curve. In addition to the slide position, the speed and acceleration profile are also displayed. Now we are going to focus on the input area of the program interface. It is divided into three main tabs: press, 3D transfer and additional movement. Let's have a look at the slide curve generator. If you want to simulate a servo machine, you can use the slide curve generator to program die-specific slide curves for Schuler machines. In general, however, it makes no difference to the simulation whether the machine is a servo system or flywheel machine with a fixed slide curve. Different stroke rates of press and transfer can be adjusted automatically with the stroke rate optimization function. You can now see the adjusted stroke rates of press and transfer on the right side of the program interface. Now we will have a look at the 3D transfer area. The Setting tab allows you to enter information for each of the transfer axes. You can enter the path of the X, Y or Z axis here. But you can also make settings for the operation mode here. In this case, 3-axis standard. If you prefer to program based on start and stop angles, it's possible to change the calculation mode to manual. In the tab Data, you can enter information regarding the transfer timing. Here you can program the accelerations of each axis and the overlaps of the transfer axis in general. With the optimizer, we can easily program these overlaps in millimeters. In this case, we start at 50 mm lifting with the feeding movement of the X-axis. The setting for the upper die allows the user to set the distance between the grippers and the upper die with millimeter precision. Let's move on to the 3D part of the software. In this area you can load the relevant model of the press. Die data can be easily added to the project by drag and drop. The 3D data can also be positioned and then saved as a project file. Other important features to note here are the dynamic measurement function. The measured results are constantly updated while the simulation is running. As many measuring points as required are possible. Interference curves can be displayed at any point in the 3D die model. We differ between interference curves relative to the lower die, shown here, and interference curves relative to the upper die. You can create as many interference curves as you like in your model. It is also possible to export these curves. Another great feature is the section view. This is so helpful because it enables you to get a good view of the components in the die while the simulation is running. Now let us turn our attention to the collision detection. This function enables the user to check for collisions and distance violations between individual components during the simulation. Let me show you an example. First, select the component you want to check. I select the upper die and the transfer bar on the right. As you can see, there is no collision. Now we will check the upper die to the transfer bar on the left. DigiSim has now detected a collision here. In the event of a collision or distance violation being detected during the simulation, this will be indicated by a red ball around the relevant position. To fix this issue, we switch to the optimizer environment. We increased the distance of the z-axis of the relative curve from 110 mm to 200 mm. Back in the DigiSim environment, we check again for a possible collision of the two components.
And all these functions are now no longer limited to machines out of the Schuler company. So they can now be used for any presses with a 3-axis transfer from all manufacturers, let's say Unlmdt.
Yes, Christoph, exactly. The Unlmdt function is a very important and new feature for our customers. With this feature, you can now simulate systems from other manufacturers. Unlimited simply means that you can use the software to simulate an unlimited number of forming machines from other manufacturers with 3-axis transfer. No matter which brand, no matter which press drive. It works quite simple. The Unlmdt machine data generator can be started with a click on the icon in the lower menu bar. When it is started, it is possible to create a new Unlmdt machine data in the dialog box by defining a name and a press type for the new machine. As an illustration of the new press, we will use the term external press as an example. The machine type is a press with a total press force of 800 tons and a servo drive. Now we need to provide the software with all the relevant calculation data for press and transfer, which means I have to specify the die space, here for example 1000 millimeters. The slide adjustment for the system is 300 millimeters. We also enter this in the dialog box. I'm now defining the movement law of the automation, polynom 7th grade. The respective minimum and maximum positions and travel length of my transfer axis are then entered into the relevant field on the screen. In addition, the maximum speed and maximum acceleration of x, y and z are entered as required. Let's move on to the slide curve. Slide curve data can be imported into third-party systems in text format. It is possible to import and select up to 10 different slide curves. I will now demonstrate this process for your reference. We open the prepared text file here and enter the maximum number of strokes for this curve in the dialog box. I will upload another servo curve 2. And finally, we open a pure sine curve for comparison. At this point, I have loaded all the curves for this machine. If you select the Press tab, it is possible to load all imported curves on demand. Let me show you this too. Servo curve 1, third-party system. Servo curve 2, third-party system. And sine curve 3, third-party system. As you can see, it is also possible to change the slide curve for third-party systems in a very short time. The transfer is calculated using the same calculation mask as for Schuler systems, which allows you to comfortably program the overlapping in millimeters, or if you prefer, in crank angles. This has been a brief overview of the most important features of the software. My colleague Christoph Kugelmeister will now show you, based on a digital process chain, which stage of the die design the software can also be used.
Thank you, Ernest. Let's take a look at the individual processes from the die design to manufacturing. Usually we start with a method plan. So we have an idea of a part and think about which forming actions and how many operation steps are necessary for it. In the following part flow simulation, we can already use our optimizer calculation software for the first time to make an initial stroke rate forecast. With the part geometry, we are able to estimate the path and overlaps of the transfer movement and the slide path. With these assumptions, we can start the optimizer, enter these values, and receive the expected stroke rates as well as the movement curves as a result. This gives us an increased planning reliability even during the quotation and project planning phase. Once we have received the order for the die, we move on to the die design. DigiSim can help from the very first minute of the design to optimize the stroke rate. This is because the previously estimated movement curves can be used to generate the 3D interference curves, or, with the newest feature, the complete safety space of the grippers and components, which can be imported and used in CAD systems. More on this later. During the design phase, it is always possible to load a certain status of the 3D geometry into DigiSim and check it with the collision check introduced before. It's possible to check if there are any interfering contours and simply change them accordingly in the CAD system. And I still have the option of further optimizing the die during the design phase. DigiSim also helps once the die has been built and is ready for production on the press. First, when setting up the die for the first time, because I can transfer the setup parameters of the press and the information one-to-one from the software, and in the case of Schuler systems, I can simply import the DigiSim project file into the system, which speeds up the die setup a lot. Additionally, DigiSim can also improve the existing setting data of already producing dies by optimizing the setting parameters in 3D and reuse them on the press. Experiences has shown that an increased stroke rate of up to 40% are possible with transfer dies. The increase can be even more or less, depending on the initial situation. Now I would like to show you an example of the previously mentioned possibilities for curves in safety areas in DigiSim Unlmtd. We usually create these during the part layout planning. So here's only the method plan with the individual steps of the components. Perhaps not fully detailed yet, nevertheless it's possible to estimate certain path of the transfer movement. I can enter the approximated overlaps in millimeters based on the part geometry. With these inputs, I can now create the motion curves in DigiSim, export them and import them back into the die design. So far, so good, so common. The problem is that only one curve is exported and the designer has to maintain the safety distance by himself. With DigiSim Unlmtd, we have gone one step further and simply converted the curves into sweep volumes. These have the advantage of representing the actual safety distance that the automation and the parts needs for the transport. I will show you live on the software how easy it is to create and use these in a CAD system. Here you can see the method plan of our example die. Grippers from a standard part catalog have also added here. As before, the movement curves can be created and exported at all points that are important for the design. As already mentioned, the disadvantage is that the entire movement space is not displayed, but only a point at the tip of the gripper, as shown here. To be on the safe side, we need the sweep volume, which can also be generated by clicking on the component. So like this. Here, for example, are the grippers on the left side. As you can see, the entire geometry is distorted via the sweep. It is now almost impossible not to keep the distance between the die and the transfer during the die design. Of course, the whole procedure also works with the parts and takes also into account the tilting movement, which you can see in the highlighted stage. So here are the highlighted components distorted over the 45-degree tilting. The sweep volumes can now be exported and then loaded into the CAD system environment for further use. So, one moment please. Okay, export finish. So let us change to the CAD system now. Here we can see the lower die of our example die set. Let us import the gripper sweep volume. Here, paste it, yes. All components of the lower die can now be checked and arranged in such a way that the sweep volume of the grippers is not violated. And we have a safe, stroke-optimized die design. The whole process can, of course, also be realized with the upper tool. Or, of course, with the parts we already created. Let us paste them too. Okay, here we go. So, that is all for the sweep volume. And now my colleague, Johannes Klein, will discuss another new and very useful feature in DigiSim Unlmtd. Here you go.
Thank you very much. Now we come back to the digital process chain. At the very beginning, there was the method plan. Then we created the setting data for the press and provided the sweep volume to the die design department. This brings us to our fourth point of the digital process chain, the digital simulation of the part flow. During the part transportation simulation, the transfer movements are checked for collision with the lower or upper dies. Such a simulation is often handled by a team, sometimes in cooperation with external suppliers. To guarantee a smooth communication between all involved parties, in the past it was often necessary to create complex simulation reports to communicate the relevant problem areas in the die correctly. These reports were overly time-consuming. To improve this communication, DigiSim Unlmtd has been upgraded with an additional feature called DigiSim ViewOnly. DigiSim ViewOnly is a license-free simulation viewer and is designed to simplify the presentation of simulation results in the future. The ViewOnly program, including the relevant simulation file, is easily sent to the customer or supplier. The supplier can open the program, including the simulation, and play it back. It is also possible to take measurements and show clearance curves. Another area of application would be to use it in combination with the manufacturing press shop to point out any problem areas in the die.
To sum this up, we have covered the benefits of DigiSim Unlmtd, including the ViewOnly feature, which helps to simplify the communication with suppliers or other departments, the design of high-quality dies, as the design can be positively influenced by simulation, the sweep volume, and the movement curves, with a shorter commissioning time that can be realized with the software, as press and transfer settings are generated offline in advance. We have an increase in safety during tool commissioning and optimization of existing setup parameters, as the offline collision control in DigiSim Unlmtd enables safe optimization. Reduced die design costs can be realized through early detection of potential interference contours or improvement steps, and the ability to increase the output of the overall system by an average of 40%. We make this possible by optimizing all movements in the 3D simulation.
With this summary, we have reached the end of our presentation.